you will see that trend. Why?
Yes.
Oh,
It
yeah.
goes up
So
and down,
forgot.
up and down.
Thank you.
Yes. Yes.
But if you want to see what happens in one wave, then this is okay. You just show the convergence, and then somebody can see that. Because what people look at, does the infection show the actual curve of the infection?
Mm.
Because occasionally it just goes up and comes down. That's what they look at. So this is what you want to demonstrate in the solutions.
Mm.
Yeah. And then I think if you want to be, you can use the exact time points in those. There is something you had lambda 1 and everything had time points. Can you open the file fitted waves LB1? You have the MATLAB file is there. I can see it in your workspace. I told you some of these things just open directly from MATLAB.
Yeah.
The MATLAB file fitted waves.
Oh. LB1.
Fitted waves LB1. Not. In fact, it was visible before you changed. I think MATLAB arranges by, is it alphabetical order, right?
Mm.
So if you want fitted waves,
Yes.
so it's
Yes,
fitted
those
waves
ones.
LB1.
Mm.
Open it. So what I think you see, no, not 285. That's supposed to be 250, right?
This one, no?
Yeah.
Yeah.
So, but they are here. You see, this STP starts from 28 to 250.
Mm.
But I told you why I was starting from 28, right? Because infection started from the Excel file, started from time
29.
Yeah, from time 29. If you read it to the MATLAB, if I read it from mine, starts from time 28. It depends with how your MATLAB is reading. So at least you can get some approximate times from this, even if you start from 0 to 50, to 50
okay.
to 450 to 500, and you see for each wave I have the times. Can you even go down? That's wave 1. Can you go down to wave 2? You see wave 2 is 250 to 450.
To 450. Yeah, sure.
And then you can go down to wave 3.
There.
450 to 650. And then time 4 is from 650 to the end. So if you want, at least, because if you want to combine, then you have to make sure that the end time of the previous wave is the start time of the next wave. But if you just want to show the qualitative results of each wave, then it doesn't matter if you start from time 0, you start from time 20, it doesn't matter. Yeah. Because if you are solving the only system, wherever you start from, you will get the same solution.
So yeah, maybe for uniformity, I think Vincent, you can use these times as well.
Yeah.
And he can read these times from the Excel file, because he's reading the Excel file. So you can read these times from the Excel file.
Oh, okay.
Just once you know them, and then you can get the time, and then you start. And so here, when you want to use this file, you will change this, whatever you are loading here, right? So you remember that one.
Oh, yes.
Yeah, because of when you compile these fitted waves, it will produce all the figures I have in the report. So all the figures for each wave, and then the combined figure.
So if I
so now what?
No,
you cannot. You will get an error. I know why you will get an error. Because this is, and we did with you the other day. This file is contained within the other file of is main fit file.
Yeah.
Can you open main fit file? And what you are missing here, just read. You only need to read just read only the data. Where is the data part? Why are you reading the data? Just go to the part you are reading the data.
Load.
No, the data. The data is where?
This one.
No, not where in this file. Where are you reading the data in this file?
It's
supposed to be before that one somewhere.
Yeah, so maybe
matrix, read matrix as a data.
Yeah, that's a 22.
22, line 22. Just copy it and put in the command window instead of running the whole of this file. No, but wait first. Did you suppress the fitting part? Can you go down and then see if you suppress the fitting part? Just scroll down. Because if you suppress, since the other file is called in this, you can just run this file.
Like here.
Yeah, you can options. No, I think you are going where you have fmin search. Go up after options. After options,
No, just right there.
Up. Just
After
down,
options.
down slightly. Function, objective function. Yeah, you see that line. Line what? Line 124. So it's commented on, because if you leave line 124, then it will attempt to perform fitting. All right. That line 124 is what is performing if you want to fit, that it's being done in line 124, where you call fmin search. And so if you don't want to fit, you just only you comment on that line and then you run, compile it. This one will compile the other LB one. Compile this one or run it.
Okay.
I know it has so many figures, right?
Yeah.
You can just start closing one by one. You see how they are appearing. You see how you see. So I think you closed so many. I just wanted us to check one by one as we go.
Or maybe can I close?
No, just start from number 7, even 17 or 18, and then you close the one. The one you see that doesn't contain any information, then you close it. So you can close this one because there's no anything else plotted. This is just the data. You click on Matlab, so all of them are hidden. So you.
Yes.
Maybe can you minimize your Matlab? Yeah, you have them here, so you can close one by. No, so you see even some of the figures you are plotting, they are here plotted, because when I was plotting, I made the code such that it was plotting also these figures.
Oh, okay.
So you see they are also plotted, some of them. So depending on the initial condition you are starting with, yeah. So the difference, you will see the difference. I think this is supposed to be which wave? November 2021 to February. This is the 4th wave. And so you see, so in mine I put the dates. So when you can also even refer to the actual dates. So what is happening? I told you that when you run for example, the cumulative, the recovered and then the vaccinated, they are accumulating, right? They are accumulating because people who are recovered, they keep on, yesterday 10 recovered, 20, then they add all those people.
Yes.
And so what is happening here, you have to keep note of the last recovered you had. And so when you run the next simulation, you start recovered from 0, right? But you add the previous people who recovered. Because the counting continues. When you say that the total number of recovery, you add everybody, even if they went back to susceptible, but they are just still counted as people who recovered from COVID-19. And so you will just solve this system, keeping in mind the same people who recovered. You start from 0, you initialize, but again you add the previous recovery. What this does is it will just like rescaling the curve for the recovery upwards. So since I have this, maybe I can upload these figures since I have them. These are the parts, because so like this figure 12, you can close it and then we see what is contained in the previous one.
11.
This is just demonstrating the fitting for the 4th wave. the fitting for still the same, the fourth wave, but now they covered. Yeah.
So this the one in red is so the one in blue is what's in the model, and then the one in red is what is actual data.
Yes, you see. So in the, you can see in
there's
the region.
a great correlation. Yes.
Yeah. So this is, so the purpose of this is just to show that the parameters you have actually
represents actual,
the model is
actual
describing the data. Yeah.
Okay.
And so you see also this is what? This is now the third wave.
Yes, third wave. Yeah, sure.
Yeah, all the waves for the third wave, right? Yeah.
And yeah, I think it's a 4. That one for the fourth wave, it was like 4.
And I did put here the vaccination, but I also put the vaccination, right? Yeah. Then you can. This is just still showing the fitting now. The fitting. Just close this fitting.
Yeah, this is more perfect.
Yeah, but fitting it when you get the perfect, it's just lucky. But so you don't have to produce exactly because you're just minimizing the distance. So I think this is the third wave now for all the variables of the third wave.
Yeah, I can see the recovered is now at 3.
But so it's 3 to power 10 to power 7, so it's around 3M, right?
Yes. Yeah, sure.
And I think there was a problem of fitting this. They didn't recover. Yeah. You see, at least this fit is not as good as the other ones.
That's true.
Yeah.
So when in such cases, I want to explain that. So what in such cases?
No, this is just fitting. First of all, one, does it qualitatively describe what you have?
But the trend is the same, only that.
Yeah, that's what I'm saying. You have a qualitative agreement.
Yeah, that's true.
The trend is the same, yeah.
And then, so you see this is the same because they are the same. So also this one.
Yeah.
And then you have the first wave now here. The first wave.
So okay.
And so the fitting for the first wave. So some of these figures, but all the figures, so that some of these are here.
Same thing to this.
So that's what I was, so that some of these figures you have.
Yes.
But so what like plotting all these variables, what do you need to show? You need to show that maybe the parameters you have qualitatively describe what maybe the expected dynamics for the disease, right?
Yes.
Yeah, where the infections come up and go down like the same as exposed, and then the recovered.
Yes.
They are increasing because they are being cumulated. I think you can just put this and then you put the way they are. So only just limiting the time. Once you have something sufficient to explain what you want, because if it's combining, already it's combined in the fitting. You have seen that figure, right?
Yes.
Yeah. So if somebody wants to see the combined effect, is that figure which you have already closed. So it is there. So here what we want to just these parameters, what will be the expected dynamics in each wave. And the figures you have here are just okay. It's only that you have to plot them now nicely.
With respect to the time intervals.
Times, yeah.
Not even necessarily the time interval. If you want, you can put time intervals. What even time is it necessary? But maybe not even. It's not even of importance. Can you check what Elias had put initially? How the figures were appearing?
Let me open the.
No, yeah, so they are there. So this is, oh yeah, so this is the same thing. You can do what Elias did, right?
Yeah.
So 0 to 250, 250, 250 to 400, and so on.
But like so that's second wave for lambda 1, first wave for lambda. Okay, fine.
Yeah, so you see, yeah, they are just first wave, second wave, third wave, and the fourth wave. And so
I
you see,
wonder
like,
why you. Yeah, I was saying I wonder why, like on lambda 1 for second wave,
yeah,
it was starting at 200, like the times to 450.
I think it was just, that's why I tell you, because this is just illustrating the solution in each wave. So sometimes the time is not even of so much importance, and that's why he did not even care to put the dates.
Okay.
Unless you want to describe maybe the time where the peak occurred, then maybe that one you need the exact time, which we can read it from the fitted wave. Yeah, if you want to see where the wave, where the peak was occurring, that one you can get it from the other figures where we fitted.
Okay.
But if you just want to see this, you should want to show the dynamics, then not necessarily, you don't even need the actual times. Yeah.
All right.
But so maybe if you want that consistent, you can just divide it like 0 to 250, 250 to
250 to
450.
Okay.
450 to 4 to 650, 650 to maybe to, is it 750 or 800, whichever.
Yeah.
Or maybe you initialize everything and then you explain what is happening, and that you are just initially, provided you just explain, you are just initializing time, but you are solving the system with the parameters in each of the 4 different waves. And so when you solve the times, I think the times, no one cares so much about the time. Unless you want to pass some message about the time, you want to look at that and then you pass some message about the time, maybe what happened. But if you just want to show these theoretical solutions, then the time is not even important. And so these figures,
then,
so you can.
But then may I have a question?
Yeah.
So in terms of will it be the meaning that we only invested with the peaks of the graphs with respect to population alone? Like if you say, time is the time, maybe time intervals, they are not really necessary. So they need the effect of different orientations of these curves, because
so you maybe let me just say, in short, you are solving the same system but with the different parameters. So you're just showing the effect of solving this with the different parameters, and those parameters they belong to each wave.
I get it. Yeah. So that makes sense. Yes.
You want to see how the disease behaves in each of these different waves. And so when you can even use the same time 0 to 250, 0 to 50, because what you just want to show is how does it behave when you compare.
Yeah.
Oh, so which one is causing having more effect than any?
Yeah, and I think it's much easier to compare when you plot them using the same time, because you can detect where the peak is occurring and how the peak is occurring. So you can just solve all these waves from time 0 to when you see that it has converged. Yeah.
Maybe.
So 0 to 250, like maybe the first one 0 to 50, the second is 0 to either to 50, 200, 300, whichever one you feel that you have sufficient, anything which is sufficient to explain. So I think these first figures will be easier to, these are much easier to draw, right? Because you have them. Just only that what you have to adjust is what? Your scale of the scale of plotting, and making sure that you read the correct parameters when you go to each wave. And then something I was wondering, because I asked something I was wondering, I saw that in all your figures, the vaccine just remains 0, 0, 0, 0. Why?
I think are they the same from vaccine? I had not actually. Let me see.
No, this is not this, just the general figure. Still the general. For example, if you go to the second, I think vaccine started in the second wave, right?
Yeah.
Because I'm seeing I've not seen here. You didn't even read anywhere. Oh, this is wave 4, right?
Yeah, that's wave 4.
So the wave 4, and you still have theta t 0 and epsilon t 0, and I think that's. And so you see, this is what I said, that when you go to from the second wave onwards, you have to take care of this theta t and epsilon, because now they are there. In the first wave, they were 0 because we didn't have vaccination in the first wave. But if you go to the second wave, they are there. So you can check these variables, and then you see which one is theta and which one. Open the variables in the lambda 1. No, where are you going to? Don't look at the variables in the file, and then you have variables. You already have them, which is pp, x1, and my param. My thing, leave alone my param. Just open x1 and pp. They have to be load line 14. Maybe clear, and then you load line 14. Clear first, so that you remove everything from the workspace. Now load line 14. Now open pp, open x1, and then open my params. Also open x1. Opening is just making sure I want to see my params and then see the position of theta and the position of epsilon, because my params has names, right? So you see theta is number 5, right?
Yeah, theta is number 5.
Theta is position 5. So because my params and x1 is just the same, it's only that in my params is labeling of x1. I label so that somebody can easily see these names, right? And epsilon is number 7.
Yeah, 5, 7, yes.
Yeah, 7. So we'll read x1 number 5 and x1 number 7, right? Can you check pp if you still have theta in pp? pp, we don't have theta, right?
Yes.
And then we have epsilon 1, because this is just taking 1 everywhere. So
yes.
That one. So that's why I say that when you read the files, you have to be careful. You make sure that you're reading the correct thing. So you've seen that. So theta is number 5, epsilon is number 7, but you have to take exponential. Because I said that some of these things I was taking the log scale. You see, even the parameters. I did put the log bar, so go to the parameters. If you use my x1, then even if you want beta, you have to take exponential of the first number, right? Yeah, if you want, for example, and also this is. But what is wrong with this labeling? Recovered. Oh, okay. Oh, yeah, the third one is just the delta. Also, you have to take exponential because I used the log scale because it was a very small number. Theta is still okay. Kappa, the recovered day. So if you want what? Oh, no, no, this is the number of recovery. So if you want kappa, it is 1/6. If you want gamma, is 1/11. But that is already taken care of in pp. In pp, you would have this 1 over these values of kappa and 1 over the 2 and position 6. So epsilon, you see, you check gamma is 0.081 and kappa is 0.1431. So they are one reciprocal of the other values. So the only thing which is not in PP is theta and epsilon. I kept them out because those ones, they are changing with the time. So that's why I decided to keep them out. Because it's a parameter which is acting only on a small portion of the wave. Not the entire wave, right? Yeah. And so maybe the point is this. So the only point of starting, if you want to put, what can I say? Because you know that this vaccination came in from time 320, right? And so the only disadvantage is if you start everything from time 0, then you will not have this vaccination effect because it starts from time 320. And so this might be the only reason you might want to use the actual times. 0 to 50 to 50 to 450, so that somebody can actually see the effect of where this vaccination started.
Okay.
Otherwise, if you just want to see the effect of vaccination, then you can just put TVAC and then you explain what the effect on varying the TVAC. But so you can go back and then read this your parameter. Why are you going to just close these values you have? Close them. And so we know what we have seen, that theta is the same as what? Theta is the same as
number 5.
x1 5.
Number 5, yes.
No, theta, line 16. Theta is x1 5. X1 at position 5. So when I mean x1 5, so it's x1 into bracket 5. Because we are seeing that theta is in the vector x1, but it's at position 5. And then epsilon is the same as what? It's an exponential of the other number, right? Because I used the log scale. So it's exponential x1 7. Yeah, so they are there, right? And so this will work for anything you have. And because I was wondering why your vaccination was just 0, 0, 0 everywhere. Can you run this and then do you still have the if command, right?
Yes, yes. Yes.
Okay. And what is your TVAC? You still put 320?
Yes.
And this is fourth wave. So fourth wave is from time 650, right?
650 to
650.
Yeah, to 650 to 750, somewhere around there. Change the start time. I just want to see the effect of this but so that is 650 because you are reading the fourth wave, and then to around 750. Also, that one you can put whichever number you want, even if it's 1000.
Oh yeah, maybe 800.
800
limit 800. You can just put any number and then you will only limit what you plot. Yeah, can you? I know something you will get. You will get blank figure. Yeah.
Why?
Because you limited your figure from 20 to 400, and so you have to change the limit of your figure.
We're raising the problems. And then,
so it's from 650.
Yeah.
So that's why, sometimes I like this when you run and then you get errors. In fact, I think that when you are learning programming, and then you get errors, and then you start questioning why this error, then you understand more. But if you are just used to getting codes and then you run codes without even any error, you will never learn. Unless you are perfect that you are doing these things by your own, by yourself, you are writing the programs, and then but if you get a program from somebody and then you don't get any errors, you will never know what the program is doing. You never understand what is happening because you are not even, what can I say? Because you don't get errors, so you don't even try to change things.
Yeah.
Right? And what is happening to this vaccination?
Yeah, even that's what I wanted to ask. That is at 0.
No, I think it's not supposed to be at 0. Can you just open the vaccination? Can you open its position number? No, can you just open the TT? When you run this, nothing goes to the workspace. Because so that's the disadvantage of using functions. But it doesn't save things in the output. So
okay.
No, can you just put some this in the code? I want to see if something will be displayed. Can you just put even after the plot, and vaccination is number?
Vaccination according to
Can you check your model? Or maybe in the region, if the region is written okay correctly. Can you check the region and then check the position of vaccination?
Vaccination
Region. Number 3, right? Yeah, so the third one.
Yes.
So can you write somewhere max Y3? But Y3 of the capital Y, the outputs of the solution. Somewhere after you're solving the system, you see how they are called Y:3, right? So just after the figure, put max Y:3. Don't put within the plotting environment. Yeah, even at line 77. Just put the word display, this. Small letters. Disp, just DISP. DISP only. And then into bracket, max of now, whatever I told you. Max into bracket.
Yes.
Y into bracket colon comma 3. Comma 3. Now, can you let me see if it will display? Just compile this. Yeah, you see it's not 0. It's only that's just a small number, right?
Yeah.
You have seen down there whatever is displayed.
Yes,
475.
Yeah, 4,700.
But so what is happening is what I told you is, this is just because you are starting everything from 0, so that's not 0. And then what happens? You can plot this on different scales. If you plot the X scale and the right and left scale, so it means the vaccination can be plotted on a different scale, right? Or you can scale vaccination. You can if you multiply it by 10, what you do get? Just go to where you are plotting vaccination, and then you multiply it by 10.
This one here
is Y3 multiplied by 10. Y3 just outside the bracket. That is 3 for the position. So if you multiply a vector, you multiply that vector by even by 100. Star. Multiplication is the star.
Yes.
Okay.
100.
And then so just run it. So what I'm saying is, so in short is, if you do this, then you can go to the legend and also put vaccination multiplied by 100. But I think there is something wrong here, right? I'm suspecting something wrong in your model. Because vaccinations will increase and it cannot decrease. And if you see that it is decreasing, can you reduce the time plotting to 700? I want to see what's happening to this, the initial point here.
Okay.
No, that one, leave it alone, because you are only restrict what, just keep that one the way it was. Restrict only whatever you plot, then run it. Just this is suspicious. Can you check your initial conditions?
Yeah.
I think I now understand the point. And you are solving the correct system with the wrong initial conditions. Now, why am I saying wrong? Because I gave you the initial conditions in the same format in which it appears in my code, right?
Yes.
And so in your code today. Yeah, so in your model, the model equations are arranged differently. So can you go to the equations? We want to see what is number one. Go to equations. And so you see the advantage of checking, because without checking, you can be solving this. So the first one is S, right?
Yeah, S.
The second one is E.
Yes.
The third one is
vaccinated V.
The fourth one is I.
Infected
The fifth
I.
one is R.
R.
And let me see how it's appearing in mine, so I know what I gave you. You see, so we could be doing wrong things, and then you. And so in mine, I think it's supposed to be somewhere. So mine, the first one is S. The second one is E. The third one is I. The fourth one is R. The fifth one is V. So interchange which one and which one. So take the fifth one, put at number 3, and then number 3 goes to 4. Just take number 3 and then you shift the others.
Take number 3.
So it means basically we are. No, not equations. No. Leave only the initial equation. Leave alone the equations, because if you change the equations here, then you have to change everything. I want to change only the initial condition.
So 3 to be the last.
If you change just put where there is no. You are not interchanging the initial conditions. You're just interchanging the positions of values in the initial conditions. Don't copy whatever you have copied. The last 0 becomes at position 3. That last 0 is for the vaccination in my model.
Then
so cut it, and then you just cut it, and then you put a space. No, just shift the other values to the other end. Don't remove them. Just put the space.
Yeah. This will be the.
Yeah, the last 0.
The last 0.
In short, what I'm saying is,
yes,
the fifth number. What are you doing?
It's the last.
You are putting so much space. I don't know. Yeah. Putting so much space, it doesn't care. If you just put only one space, is okay.
Okay. One.
What are you doing? How many things do you have, Nandwa?
I mean, there's one position being.
The only thing we wanted you to do is take the last zero, put at the third value, and keep everything intact. So you have removed the last zero. I don't know, because there are two zeros at the end. So only one zero was coming to number 3. Yes.
Yeah.
The same to all those IBs. Just put there zero. Don't even copy. Put there 0, and then you remove the last 0. Remove one of the two zeros. But it is good that the others are okay. The first one is okay, right? Because the first one is okay. Yeah, now continue.
Now it has shifted from the y-axis now.
Yeah.
Yeah, shifted from the y-axis, right?
Y-axis.
But again, now still, what is happening? Who knows?
No, I think it's still the positioning in the model, because I think all the 3 values were interchanged. I mean, the 3 initial conditions.
No, because I just wanted to arrange the initial condition according to his model. His model suggests what? That the first number is SEVIR. According to Nanda, can you check your model equations? And then we rearrange the equations according to that. The first equation is for S, right?
Yes.
The second equation is for
E.
The third equation is for V.
Yes.
The fourth is for I. And the fifth is for R. Yeah. Yes, I think this is okay. And so this condition should also come in the same
order.
In the same order as the equations.
Okay.
Yeah. But some people put spaces. Do I also put spaces? Or you put semicolon? Can you put comma? Because I'm sure I'm just sure we're separating them with comma, but not space.
These values.
No, it's still okay, but just to be sure, I always try to separate them with commas. A comma, just separate those values with commas. But I'm not saying that there might be no any error. This is just to be sure that maybe you are not making any mistake because of putting the space. Now, can you increase the plotting range and also the solution range?
So we'll keep this
700. Leave alone those other y limit values. So instead of the 700, just even put the last time point, which was there initially.
800.
800.
Yeah. No, but I think there is something wrong, right?
Yeah, I think, in like Dr. Juma, in what you have said, like how are they appearing in your model? It seems like all the 3, I mean, the last 3 initial conditions were, I think, just to check like how they are appearing in your model.
Oh, so in my model, it is SE. Those were okay. And then I.
There it changed.
And then R.
You see,
and V.
Yeah, so the recovered came before the, I think they vaccinated.
So according to his model, the I is number 4, right?
Okay, can you go there, Nandwa?
Can you go to initial conditions?
Yes.
I is number 4. And then V is number 3. Right?
Yes.
Yeah.
Well, in yours, it's I number 4, and the R is I number 3, R is number 4, the V is at the end.
Yeah. And that's why I was suggesting to him that he changes the last value and the first one.
Oh, okay.
So, yeah, no, the last value, because which was V in mine, and it is the third in his. So that's why I say that he takes the last value and puts in the third position. So you see, if you replace the fifth in the third, then I goes to 4 and R goes to 5.
Okay. Yeah.
Unless if you change the equation, but
no, I think no, this is fine.
Theta. Can you display theta? I want to see what is this theta now. No, can you display here? Just put somewhere display theta. Maybe it will display 0.
Okay.
No, display theta t.
In the command window?
Just command window somewhere where you write anything.
Okay.
Where you are displaying the other marks. Can you display YT? The same point you are displaying the Y3.
In the code. It's up there, I think. Remember where we wrote.
I forgot where you put display this DSP.
Yeah, there. Yeah, there.
Also DSP theta.
All right, create another one, display.
Yes.
Theta T.
That one.
Now continue. Run it.
No semicolons?
No, it will not, because you still want to display it. Just run it. So this is not 0.
No.
Vaccination cannot be 0. Why is it 0?
Yeah, it's not 0.
Can you just do something? First of all, what is your TVAC?
320.
How is this thing counting the TVAC?
Okay.
No, because I'm just wondering, how is it counting? Does it count the 320 from 0? But it has to take in the times where this 320 is. Can you put the starting point instead of 600 to even to 400? I want to make sure that whatever the range we have is beyond 320, right? Can you put the starting point even to 200? Even to 200?
200, I think.
No. I just want to see how it is dealing with this TVAC. You see, now you have, although I don't know whatever is displayed.
Yeah. No, it's the plot is still from 60. 50.
Yeah, the plot is still, but at least you see now that we have the TVAC from 594, right? So it means we are having vaccinated. And so now the question is, why? What is being taken in the other end? Okay. Can you go back to your? I think I know them. Can you go back to your putting the D45? If you, he says no, but no, but in that case you have T. That is okay. I think this is yeah, you have T, which is okay here. Now, can you go back to your model equations? Why is this? If TVAC is less than TT, and Can you go back? I want to see that function. Yeah, so it is TT. In fact, you are.
Yeah.
TT, comma 1. I think this will be strange.
Yeah.
Because it should not, unless it is starting from 0, because unless it starts from 0, so it's assuming that the other things are. Can you start from 320 exactly?
Starting time.
No, I want to try something. Can you start from 200 to 400? And for now, maybe just run it, even if we don't get the graph, we'll see whatever is displayed. Yeah, we have our value displayed, right? Because I'm just looking at the maximum value for the vaccination is 59. So it means this thing is, in a way, it's working a bit. Now, can you go back and change the other two things, shift them up, the starting and the end?
So say 300.
Even I want to skip the 320, so put even 400 to 600. Okay. Oh. No, so it displays 0. Why?
So does the X lim has like any effect?
The X lim is only has effect on the plotting, and you see,
okay.
I'm seeing the value I'm displaying. You see, it means, and we are displaying the maximum vaccination.
Yes.
And you see here, if you go beyond 320, it tells you that the maximum vaccination is 0, right?
Yeah.
It means we are not, the vaccination curve still remains 0. Hey, this is now strange. And remind it, can you go back to that part again? Because the question I'm wondering is, why does it, if you start beyond 320, then it does not work? Can you put in the start, can you put there in the other values, just in that start time to end time, maybe put colon in between, but I think colon will it work? Can you just put start time, colon 1, colon end time? No, in line 52.
Colon.
Yeah, colon 1.
Colon 1.
1, colon, and yeah, the 1, 1, 1. Let me see if this is okay.
1 also. Okay.
No, that's, you always put 1.
Okay.
Yeah, I know it will tell you to group. Just run. Why do you put the space? But still no error. But just continue. Still it's 0. I think there is something wrong here that I don't even understand what is happening.
The multiplication by 300 doesn't have any effect.
No, that one you are just multiplying whatever we plot. We are not even multiplying
so that it's
the output.
All right.
We can do one thing here. Nando, can you separate this? We can avoid this way of using functions. Can you extract whatever starts from the function part of the model? Yes, from line 119, where the function is starting until where it is ending. I think says cut that. Just Control X. Then create a new file, Control N.
Control N.
So let's, yeah. And then you paste whatever you have, Control V. Save. Okay. Just save it.
CL.
As a CL.
Because it saves with the name of the function. I told you this the other day.
Okay.
It has to save with the name of the function. So this is saved. Right? And then can you go back to the other file now? The general file.
Yeah.
Remove the function at the top. Just remove whatever you see in the function on the top.
Function
general. Delete that line.
So
delete the line function. Omit. I think it's the first number, first line.
Yeah, first line.
Remove the first line. What is the other end? Is it for the function or for the loop? The last end at the end of the file.
I think it's already suppressed. Oh,
no,
okay. Oh, yeah.
Yeah, remove. Yeah, that one.
Remove.
Yes.
It out again. Okay.
Now run. Then see what. I like this. When you get errors, can you go back and go up and then we see what these errors and recognize function TVAC. So that's the problem of this is the problem of just go back, go up and put the global variable. Go up and after all you put global. You may want to put all these parameters at global, so you just put global and then you space. You don't put any semicolon. Write whatever is saying is TVAC. In short, write all your parameters because it will give errors of all the parameters. You just leave the space is TVAC beta.
Space, of course.
Space, all of them you leave the space. Beta. Even epsi t. I think even epsi is not necessary because epsi is the other end. So what is necessary is only the psi t. Psi is not necessary here.
Theta t.
Theta t. K. Just names of K capital. Just names of all your parameters. K, sigma. Write them in any order, provided you write all your parameters.
In the order they appear?
No, not in the same order, any order.
Okay. I think you have mu.
You have V. I don't know if it is capital or small.
Small.
And then you have
phi.
Phi. Have you finished all of them?
I think that no, it could be should be one. Can you go down a bit? Yeah, so we have divide.
You did put cap.
Yeah.
Any other parameter? N not, because it will be required. N not, you may need it, you don't know. Just put all the other parameters also in that N not.
There is Q.
Yes, yeah, there is Q somewhere.
Yeah.
That's the advantage of reading parameters. So if you read the structures, then it's much easier. You just only call the structure in your model. Now, can you copy line number 6 to the other end, also to the model? Just copy the whole of line number 6. But again, there is global. I don't know why it's underlined. You will check why it's underlined. Copy to your model equations. Model equations are saved in CL. Why are you still checking there?
Anywhere?
Before equations start. So it's something somewhere before line 3. Can you check that's it's global is underlined? Can you check what the global is underlined? Use. Can you put details? What is this suggesting? Global variables have their own workspace, which is separate from the base and function workspace. Memory is inefficient. Matlab applies memory optimization to input variable in functions, but does not to global for more information. Hi. So these are so many. Why is your Matlab today misbehaving with this so many errors? Just go back and the other end and then compile them and then see what you are getting.
This one is
save this.
Yeah.
You did you save
no,
it? CLM.
It's not saved. Oh, okay. It's saved.
Now go back to your general model and then you compute it. But you still have the same error. So this, I don't understand. I don't understand why. Can you go back to your model? But mine is working. Can you go back to your model? So does it mean it first needs this to just go back to CL? If T and else T is equal to theta T. I have so many of these ifs in my codes, and they don't misbehave the way this is misbehaving. And I'm wondering why. Can you, I don't know if it is display, can you put
Hello.
I'm looking at how maybe you can rewrite this to, but it's the same thing to make meaning in MATLAB, to have a meaning. Did we put the wrong things? How did you write?
Let's check. Let's check the model.
No, we wrote, no, it's called, we wrote the wrong thing. It's supposed to be if TT is less than TVAC. So we are solving our system, but with the wrong.
So it should be the other way around.
So just put if TT is, don't put greater than, just put if TT is less than.
Less than.
And then so remove the other. Yeah, so we were doing, but so we are doing the wrong things. So because so we are saying that if this T, and we're saying that everywhere T is greater than TVAC. No, so don't change anything. It's just only save it and then you run. So it will now produce the results we expect.
Yeah.
So you see now number is greater than 0. Now plot the initial time, the initial values you are plotting. And I don't know why this one bypassed us and we didn't even realize.
So initial times to be
just the way you had put initially, it was 650 to something somewhere.
650.
800
to 800.
I told you that when you plot, put any maximum range you want when you solve, and then you can only restrict in the plotting. You don't have to put only 800, right? You don't have to put 800, not necessarily 800. You can even put a value beyond 800. So what you only do is, because how sure you that it will converge at 800?
Yeah.
You are not sure, right?
Yes.
So the only way, when you solve, give it sufficient enough time, and then when you plot the only region you want. Once you feel that now this is okay, this is enough. Is it okay? Now can you remove -10 now in the now remove -10 in the plotting? No, times 10, because you multiply by 100.
100.
In fact, it was times 100.
Times 100, remove it. Where we plotted and then multiplied a number by 100 by 100.
There.
That's by 10. Before
No, remove. I just put it because I wanted to see this number, why it was so small. And now it's not necessary to put there. Yeah, you see now how vaccination behaves. So now open this file. So this is one of the effects of intervention, right? Just enlarge this figure so that we see that. You see, the disease was growing naturally, maybe let's call it natural dynamics without any intervention, right? It grows, it comes back, but when it reaches time, maybe somewhere time around 670 or 680, when it was starting to get down, and then you set in vaccination, right? And so that's why you see this curve is, you have some wobbles in the curve, because now you have you had S feeding directly into the vaccination, right? No, into the infections. But now when you bring in the vaccination, so some people are being diverted. Let me just say they go to vaccination before they go back to infection. And so you see, this one changes from what you had initially.
Yeah.
If you want to see the differences, can you put just vaccination to be 0, 0 everywhere?
Vaccination.
Just copy line 16. Copy the two values, the line, so it's now line 17. Copy theta t and epsilon t down, and then you put them 0. No, don't comment on the other one. Matlab takes the last value, so just put the last one. This other 0. But so when you want to use the first ones, you will comment on the last ones. Now run and then see what you get.
Yeah, big difference.
Yeah.
So you see the difference.
Yeah.
Yes.
So that's the effect of vaccination. And that's why I wanted to see what is the effect of vaccination when introduced at different time points. You can check this. Because you have seen that into introducing it immediately, you have seen how the curve behaves, right?
Yes.
So they behave different. So you at least you can now notice the difference of the difference of what in that vaccination. But so I think the first one, you can plot these figures easily. Is there anything else we need? In the first part, only producing these figures, because the only thing you need is in fact nothing, only the initial condition
and times drawing them during different times.
And only you read the correct file.
Hello.
You call the vaccination.
Hello.
Hello. Yes.
Yeah. Oh, you are saying hello.
Yeah, I was not hearing you clearly.
Oh. Maybe it was your net, right?
Yes, yeah, it was his net because I was getting you clearly.
So what I'm saying is, so the first part of the figures is okay. We just need to put these actual times because of this vaccination. It started at some point, but otherwise, if you don't have vaccination, then you can start everything from time 0. Yeah, and then when you now bring in this vaccination, you will see how the curve behaves, and that gives you something to explain in the figure. So you are changing the natural course of the disease, and then you bring in, because of that intervention of vaccination, you see that the disease course changes. I think this is okay, right? The first part is okay, right?
Yes.
And you can report these figures.
Yeah.
Huh?
Yes.
If it's not okay, you say it's not okay. If there's something which is not clear, you say that's not clear.
It's clear, so because actually, so the transformation I'm going just to do is for this case of vaccination now from 650 to 750.
There is nothing you change about vaccination because we have already put the correct time which was misbehaving the TT. The only thing if you go to the first wave, you read, for example, time 0. Just solve it from time 0 to any large time you want, even if it's 500, right?
Yes.
Provided just start from the actual time 0, and then you solve it from to any time you want. If you go to the second wave, start from time to 50, where you want, right?
Yeah.
You are giving the maximum time so that in case it does not converge before the actual time, which is surely because fitting it showed convergence, and then you can now you have enough time of floating. In fact, if I were you, I can touch on the time end, the T end, the end time or T end. You can put 1,000 and don't touch it. You only touch on the start depending on the wave. So if you have first wave, you put T start 0, second wave T start to 50, third wave T start 450, fourth wave T start 650.
Yes.
And then you keep the same end time. And then so when you plot, if you know first wave and then you see at 250, it shows convergence, or at 300, then you X limit that range. Yeah, but so T start, keep it as
so if okay, yeah, like I wanted to ask you, like, if this CL function is now brought back in this main one,
it will work. It has to work. So the only worry, because since there was error, I didn't know where the error was coming from.
Oh, okay.
I was just trying to move around things to see where the error was coming from.
All right.
So there, but so the reason I like it outside, you see, outside when you compute it, then you have values appearing in the workspace.
Oh, okay. Yes,
you can double click on even Y, the Y capital. Can you double click on Y capital in the workspace?
Workspace below.
Workspace is below the current folder. That is editor window.
Yes.
Y is there. You have capital Y, right? Yeah. Y is the out. So you see now you have how many variables? The first, the second, the third, the fourth, and fifth.
Right.
And so I wanted this because you can easily look at these columns. And then the third column is what? Vaccination, right?
Yes, zeros.
No,
Yeah,
I think it's not. I think they're not all zeros.
T.
The third column is vaccination. Yeah. Can you just go down, scroll down? They are all zeros.
That's
Why?
theta. But I think because we have put, you said
MATLAB
Pepsi, we had actually put them at
We
zero.
have put theta 0.
Yes.
And so you see the advantage of this, you can easily see these values and then you can compare what you have. But when you have function, it doesn't save. So you have to save it maybe. But so these values will not appear in workspace. You cannot even try to study the parameter you want.
Okay.
But so whether you put in the same outside is the same thing. And so, but so the advantage of putting outside, you see how can you close that one? How Elias made it, that he made two different models for the COVID and general model, COVID-19 model. But so if you put outside, then in the COVID-19 model, you don't need the model outside because you have the model already defined in this there. So both of them will be using the same model outside.
The same model, okay.
Yeah, both of them will use the same model. And then so you see that what you have in the end down, can you go down? Where the model equations are written. And so this part can be removed. You can remove this part because you are sure that now it's appearing. It will use the other end.
And in fact, it still has that error.
That mistake, yeah. I see.
Just delete the whole of that one since it will use the other one.
Okay.
Yeah.
And then also remove what you call the function. You also remove that. Just remove that end.
End.
Because it's for the function. And then remove what?
The top function, the first line.
Yeah. And so both of them will be using the same function. So you don't have to type the function twice. And maybe you'll get an error. It's good that you didn't get an error. But so now you notice something we said here, right?
Yes.
That we no the initial conditions. You see that now we change them the other end.
Yes.
Just go and copy the other ones and then bring them here.
Just all of them there. They were.
Yes.
Okay, fine.
They are the same initial conditions. I told you that these things is the same equation. The only difference is what? The looping here, you are just looping, but everything is the same.
Okay.
There. In IC4.
Yeah.
Okay.
All of them, and then you can copy them to the other end. So I told you everything from the parameters to whatever initial conditions, even solving the model, is the same thing with what is in the general model. Right? In fact, you can use the same file. I know Elias wrote 2 files because he had written this in a different format where you put the looping index in the model. But so you can use the same file to perform everything. And so the difference between this and the other is just only the looping.
The looping one from H.
You know what the error is, right?
I see.
And check the line number. Just read the error, check the line number, and then you click on the line number. So what is that error?
We had put :1.
No, I think that's not even the error. That was also just trial, but that was also not error. That's also not an error, even if you don't put 1.
Okay.
Just putting 1 ensures that if you put those numbers, you are telling it that I want to save only these values at the specified time points. But if you don't put, then you may find that it saved values maybe at time point 0.1, 0.2, maybe 1.5. And so you want only these values saved at the days, like 1, 2, 3, 4.
Okay.
Yeah. And so I think the first one is okay. Also, the figures, you can also do the same thing to the figure here, because you see this figure has still the gray background. You can change the background of the figures. You know what we did in what I told you.
Grid on.
Yeah, there were some commands.
You see, can you run your general model?
The GC something.
Yes, you are changing the. I told you that you see this how the figure is. So because you want uniformity in your figures. So can you change copy those two lines, the GCA and the GCF?
GC, yeah. There.
After hold off, because that's just after hold off, after the end of the loop for plotting. So after hold off.
I think it's
hold off
below.
is down.
Yes, there.
And even after legend show.
Okay.
Because we want also legend to have the same format. Now can you compile this figure? You see now, so it also has.
Yeah.
This is just like what I said. So whatever people will have different preferences, but you want your figures to be uniform. So what else do we need?
So for this one, it's only like one graph showing up at the thing.
I think mostly what you want to see is what is the effect of these interventions on the vaccination, right? No, not vaccination. What is the effect of these interventions on the infections, right? Infections, mostly not even the daily recovery. So you have to check what are you plotting. And you see the reason I said that and the reason why now you're struggling, because you got this code and you didn't struggle to look at what each line is doing. And so you are not sure if I want to plot vaccination, how do I, if I tell you here that plot vaccination, how do you plot vaccination here? How will you plot vaccination?
Number. Well, I have to hold others Nanuache number, only number 80 by 3.
Check where is he plotting his variable.
I think it's on 7. Oh, no.
Nando, are you seeing where he's plotting?
This plot is here.
Yes.
On line 72.
72.
Line 72.
Then I'd have to change this one to be 5 to 3. Change 5 to 3.
So 3 what do you want to plot when you put 3?
3 is vaccination according to the order of the.
Yeah, and I said we want infections. I think that's mostly what people want to see, the trends on the infections. But you can put all of this, whatever you want. You can put all of them and then see. But so you don't want to see maybe vaccination. You want to see mostly what is the effect of these interventions, but you are still kept 5. But you want to see the effect of these interventions on the infections, right? Yeah, but you can do both. You can put infections, you can put the recovered. There is something wrong here. No, this is vaccination and time 0 is vaccination. So that's why I tell you, first, don't worry about vaccination. We want to see the effect of those ones on the disease, mostly like the infections. You are still putting number 5.
I think it's the
infection is number
SEI.
Even
number.
E is also not important. Even what's just important might be what is more important is mostly the vaccinations, right? Yeah, because
So
people are only worried about 4 vaccinations.
It should be 4.
Yeah, it is 4. That means you have to look at your model, understand the things where, for example, if you want to change something, then you can easily look at whatever you want to change and see how it's appearing. And so here's delta. Mostly the delta will not have so much effect on this, right? Delta is the death rate due to the disease. Mostly, if you want to, maybe you may want to see this, but so, yeah, but so I said that vary most of these parameters and see those ones that gives you something which is interesting, right? And so, because in fact, I don't know if I asked you on WhatsApp that I saw all your files were able to recovered. So when you plot, you have to be careful. When you put, for example, infections here, so you have to change the Y label and you put the appropriate. Right? Yeah. So if you are putting so you put the infections, this so you put the appropriate value.
So like for if I were to
the Y label, I just saying first the Y label.
Yeah, like there.
Yeah.
Instead of the recovered population, we are looking at the vaccinated, I think.
No, infected.
That's 4.
4 is infected.
Infected, yes. Yeah.
Let me just say.
Yeah, so you change that the Y label. Can you vary one and then see what is happening? What is your time range here? So I told you that when you want to vary this, just start even from 0. No, can you put the time range from 0?
Yeah, it's starting at 100, I think.
So no, so and where is your time points? The plotting time.
It's below. I think it's starting at 100 if I...
No, I want Nano to say where it is. No, don't go at the general model. Keep the same COVID-19 model. Start time and end time.
That's...
Do you see them? Can you go up? No, because you know that you cannot solve your model before declaring time.
Yeah.
In fact, so when you want even to look for, you know that it has to be above the solving part.
Yeah.
So you just put the starting time from 0. And I told you that the end time doesn't matter. You will restrict whatever you want to plot, right? So put just the starting time to be 0.
Yeah.
Right? Yeah. And for now, because for example, which parameter do you want to vary? And just also use even the first initial condition.
Let me now pick. Let me pick beta.
Yeah, we want to see the effect of beta, right?
Yes. It was line number. Let me just. I'll change it to be beta.
And is your model?
Yes.
In your model, do you have delta or do you have the word delta written just delta?
Delta.
Can you check your parameters? Do you have just delta written as delta? And so you see, you change the parameter, but that parameter didn't have any effect on you. That's why I was wondering, because your solution was just the same curve, but different times. So even when you know that the delta is the death rate, in your equations here, it is written is the parameter sigma. So check the equations, how it is. Is it written sigma or delta? Check equations not in the PDF. In the PDF. Model equations. Death due to the disease is delta, right? So here it is written the delta, but in the other end, whoever did it wrote sigma, but you know that delta and sigma are the same. So you label it delta, but you vary sigma when you are varying, but the labeling is delta. You know, sometimes when solving, even if you put a sigma in the model, provided you put the correct parameter, but you keep in mind that this delta, this sigma here is the delta in my model. Yeah, so you have to make comparison. So
Okay.
and so I was wondering, that's why
Yeah.
the equations were
Gamma mu. Okay.
your equations were only clamped at.
Yeah.
So can you replace delta to sigma? See what's happening. First of all, just keep the same delta. Where that line where you have changed, just is it line 54, line something? Where you are trying to change to be, can you try to put sigma? So you have to make comparison of the model itself and the computation, so that whichever you vary here, like here, right? The sigma here refers to the delta in the model.
Delta.
Now run it and then see what happens. But still, this is the same thing, right? It's almost the same.
I had to change. There are two things to change. Maybe.
Which one? That's just labeling. I told you that's labeling. So the labeling should correspond to the model, because when somebody is reading the article, they will not see these Matlab codes that you put sigma. So the labeling should correspond to the code, to the actual model in the paper. But so that's why I'm saying that that sigma, varying sigma is equal to the delta. Can you put beta? But this is strange.
The same as well.
Can you reduce the plotting time?
Say 0 to 200.
Just whichever you think, any that's appropriate. But I told you initially that you only limit the what you plot, but you just keep this this other one intact. So what does it mean? Does it mean that beta does not have any effect? I doubt this.
What's our beta in?
It's a function is the transmission rate.
Oh, okay.
Can you just go back to your parameters? First of all, let's see what we are reading.
That's the parameter in the code.
In the code.
Beta is.
Where you defining your parameters.
By the way, is it like I have just one constant?
No, but I told you that now everything will be the same as the other end. So you have here parameters written manually, and you have the parameters the other end. Can you copy whatever is the general model, then paste it here? Starting from loading, why not loading? Why do you want to put things that you don't load?
Okay. So I replace by everything here.
Yes, I told you that these things will be the same. But yes, you still have the same results. Can you just read the first wave? Read the first wave, the parameters for the first wave.
So
that's wave
1. Huh?
1.
What else is? No, but
I don't think anything changed.
Can you verify? even labeling now doesn't. We just want to see first the output before we'll see how to label.
No,
I think there's a problem somewhere, right?
Theta is the one is almost in the R note. Theta can we try that to see whether there's any change?
Can you try theta? Because also this has to change. Don't struggle about label, just only want to change the input.
No change.
No, this theta, I know the reason for this theta, right? Can you go to the model?
Theta T?
No, or maybe, can you put TVAC 0 for now? Put just TVAC 0. TVAC, where did you define TVAC? Put it as, just put as 0. Copy it, put down, and then you put. Well, because I want immediate vaccination to set in immediately.
Okay.
Now proceed. I think there is a problem here, right?
Because this one is not changing as well.
Yeah, this is not changing. What are we solving? Can we go back to, can you now check these files? Epsilon, theta, no, theta t. Yeah, you put, you are supposed to put theta t. Where you put in the loop, where you put theta is supposed to be theta t. In the loop, where the loop is starting from. Where you put theta is supposed to be theta t in, where is it, line 53?
Yeah.
Yeah. And then can you put epsilon t not 0, just n and 0 number, epsilon, not n and 0 number. Epsilon t. Just even, yeah, you can even remove whatever. Yeah, even 0.5. So there are some problems here. Now, can you check your model? Can you check your model? No, not. I just want to check the whole of this file. No, wait. Yeah. So this is, you have parameters. Can you just go down, define, and then you have. You are too fast. I cannot even see what you have. Theta t, theta. Can you now go down? Epsilon a. Just keep going. Where all these other comments, you can leave them, because then can you for now? I said, can you for now use LB1, IC1, the first initial condition. And also, no, I don't think so. But I'm just saying. So we want to read. Can you go down, because you have to change your initial condition in the model?
So this one.
Did you put theta t in there? Did you define here global parameters? You didn't.
No.
Can you define? Can you copy the line for the global parameters here? You cannot define them after you have declared parameters. You cannot. Now just keep going a bit faster. Just go to, this is just no, can you, oh, so you skip now everything. Some of these comments, can you remove them? So here we are plotting the plot y4. That is which is okay. Can you down? Just keep going down. When you are labeling, those labelings are not enough. They are not necessary. Font weight. Just go down. So this is the end. Now, if you now run this model, you see now
there's a change.
I think the problem was that, so this thing, since you declared the global, it was probably still using the previous parameters. And I think that's the comment you are getting about the global variable. That when you use global variables, you might get the errors. I know how I use variables. Mostly I don't use global. I just put parameters as structures. And so in that case, it's much easier when you put them. I call the structure PP. You combine the PP in the equations. When you don't want to put the global, can you do this? I don't know if will I remember how it's done. Sure, maybe I'll check. Can you just close this figure? But now at least now we have seen that's working, right?
Yeah, it is.
Can you copy just all those parameters from the TVAC whatever and skip the word global? Just copy, not copy parameter values, parameters at the global line. And then put them in the model. So you have no, just go up. Just you have t comma y comma t comma y comma in the first line.
The function line.
Yeah, within, and then comma all those parameters. You can put them commas, comma everywhere.
Each of them, huh?
Yes. And then they are being highlighted because of the global effect. So you remove that global. So I want to define these parameters. And then after that, you comment on the global. And then I said you have to put comma n note, because I just think because n note is not being used, so that's just it's just a warning. That's not a problem. So can you go back to the other end and also put the same parameters? Just maybe it was easier, you could have copied them from there because already they have commas.
Yeah.
Copy them, because if you copy from here already you have commas everywhere. And then also suppress this global. And then you go and put them in the model. Where do you have OD 45? But maybe they will be too long.
There.
So at CL, options, and then a comma, can you try to put their parameters after options? Let's see if it will work. But I know what, sometimes you have to put maybe maximum. Can you just run and then, because if you have an error, it will tell you that yeah. So this works, right? So at least now you see, at least now you can speak of the effect of what? Effect of this vaccination, right? Yeah. Now can you change another parameter and then see?
So so should we be we should use this letter T to name them, or it was just by if
I named theta T is only affecting vaccination, because vaccination, you see, we are calling it in a loop. Because in a loop, no, in the if, I think that if, then theta is equal to theta T. So that's why you only have to vary theta T, and you call the other end the right theta.
So if we use now epsilon.
Yes, also it's supposed to be epsilon T, because epsilon also, it also has to T, right? It also has T somewhere. Epsi T.
Epsi T.
And remember, when you went to vary epsilon, there must be effect of vaccination. So you have to give vaccination some number. Can you give vaccination some number, even if it is 0.2? Or but just comment on that vaccination, keep the first one. The first one will be 0. Not TVAC, vaccination, not TVAC.
Vaccination.
Theta T is line 17. Even give it 0.2. Because you cannot expect epsilon to have effect if you are not vaccinating. Yeah, now continue. Yeah, so you see also, at least also maybe this one has some effect, right? But we'll see what is happening, and because you have some but what I'm saying is, at least now you can see that when you vary these curves, you are having some.
So the thing that
some effect.
There will only be change come up. Theta.
Sorry?
Define on this one.
Which one?
On vaccination, so theta and epsilon must be set to be non-zero values at the same time.
Yeah, because if you want to see effect of vaccination, then efficacy can be 0, but efficacy cannot be. What will be the purpose of vaccination if efficacy is 0? Then there will be no need of vaccinating. And so those two things, when you want to vary the effect of these vaccinations, you want to see the effect, then both of them should be one. If one of them is varying, the other should be non-zero. Now, can you vary another parameter and see? Like even now, phi, we are trying the phi, we are trying.
I think now they are bringing different.
Yeah.
But I do so we'll have to understand what is. Can you plot only a few of them? Maybe not even 0. Can you plot even non-zero value? But if you have phi 0, it means what is the red line? Oh, yeah, I know, now I understand. Because if you have phi 1, if you check how lambda is appearing, if you have y1, then the forcing function is 0. That lambda is 0. Can you check just the equation of lambda? Even in the PDF or whatever. Can you check equation of lambda? Because it's above, it's equation number 1.
Number 2.
Equation number 1. So just go up.
If you go up PDF.
No, this is equation 2. So go up your PDF, move up. You see lambda is equation number 1. And when you set phi to 0, what happens? The whole of that expression goes to 0.
Set phi to 1.
To 1. If you set phi to 1, then the whole of that expression goes to 0.
Goes to 0, yes.
Yeah. And so it's expected that when you increase phi, then you decrease infections. right? Phi is the control. And so, and you can see if that's what you are expecting or what you are seeing. But so that's what is expected, that when you increase, phi is the control measure. When you increase the control measures, then you are reducing the number of infections.
Yeah.
And so you can even verify that one against what you are observing. Are you exactly getting what you need? Right? With epsilon, you see that when you increase epsilon, you also reduce the infection. So I think you can also even verify this against what?
Yeah.
We can also verify this against the sensitivity. Look at, for example, the parameters which are like beta, which is positive. But if you check the PDF, you'll see the sensitivity. Check the sensitivity graph. I think it's one of the, almost to the end. Just so, I think it's the last graph, right? Did you download the latest file? Yeah. So you see which values are increasing the R naught. I think if you increase R naught, that it means you increase the infections, right? So the expectation is, if you increase phi, you decrease infections. We have seen that is true. It's also expected that when you increase delta, you decrease infections. When you increase gamma, you decrease. When you increase epsilon, when you increase k, when you increase theta. However, when you increase beta, you increase infections.
And when you increase,
and that's even physically it's okay, because when you increase the beta is something like the contact rate, right? When you increase the contact, people interacting, then you are increasing the number of infections. The likelihood of people getting infected is high.
Yeah, that's true.
Yeah, even the same as kappa. So it's also expected that if you increase kappa, so that's what I'm saying, that mostly the results you get may or may not correspond to the sensitivity analysis. But we can even use this to verify against the sensitivity analysis. As we have seen some already, I've seen that phi, that when it increases, then you are decreasing the infections. Can you try beta now, or even the capital K?
So capital K.
Can you increase beta? Even leave alone the first K.
This how capital K is.
Yeah, you can also check capital K. No, but so the problem is you cannot vary capital K from 0 to 1. Capital K is in order of population, so it is something in millions.
Millions, yes.
So when you vary, don't just restrict yourself to 0 to 1, because you look at what is the meaning of that parameter, and what is the range of that parameter. You can just put even 1 e to power 7. Just like E7. Yeah.
Small.
Whichever, capital or small, both of them will work. This it's not an exponential. This is a shift operator. It means it's 1, then 10 decimal places. And so maybe this one, noticing what it's doing, not easy, right?
Yeah.
Can you plot only maybe, even can you reduce the number of curves you plot?
So say to 3.
Yeah, even to 3. So which one is blue? So it means, what does it mean? When this is small, then you have less infections, and when it is high, no, can you check the magnitude? Can you enlarge this figure? Where is the peak?
Below?
No, I don't know what's happening around this point. I still have to check. You have to verify if you are solving the correct thing, right? Because why do you have a surge somewhere here at around time 40, right? Before they go down, because you have the elongated timer. But so what is the peak? The peak, in infections, the curve which goes on which goes higher decreases faster. So according to this, blue has highest magnitude, has highest peak.
Yes.
I think it's behaving as the sensitivity, right? That when this increases, when phi increases, then the peak decreases, goes down. Yeah, because the lower the infections, the longer it takes to die out. And the higher the infections, the faster it gets to die down, to die out. Yeah, that's what's expected. That's why you see people say that if you want people to, when you want to control this, let it infect people, and then. But so the problem is, so what people get worried of is you are overloading the healthcare. So will they manage to control, to take care of all those very high number of infections?
Yes.
And so what you do is you are trying to balance between living the disease for so long, but to the level you can control. Not that you leave it that it's very high. Maybe in 1 month you have million infections that you cannot even control.
Although
it will die up naturally because
easy.
everybody will become immune, so it will die naturally. But so many people might die because of the disease. So anything else we wanted to vary?
So those
just try beta.
Mu?
Just try beta, but I'm
beta,
getting just I don't know what is happening. You will remove at some point. You will have to remove this global effect even on the COVID-19 general model. You know the problem of this thing. You might still be using the wrong things somewhere. So you do the same thing what you have done in the COVID-19 general model. You remove the global effect and copy these parameters at the other end. The same way you did to the model here. And you might copy even now, because if you don't copy, I'm sure maybe you may not even go and copy.
You may forget.
In the solving part. Just go, and then you go and copy them also in the general name. And you remove that global.
I think it's up there.
No, it is now 52. I think it's 52.
I comment this first.
First of all, you
like
remove the global.
Yes.
Yeah. And then you
after options.
Yeah. Then you just also run this one so that you see what you get. Okay, but sometimes just to be sure that it's not using the wrong things, you will close Matlab and then you open again so that it deletes the previous memory. But that one you are finished. So we are going to the other one of varying.
So we vary mu.
You vary?
Mu.
No, what we know the point was now you know what it's doing and you can vary all the parameters you want, right?
Yes.
Yeah, because now what you just have to that when you want the effect of vaccination, then both of the two must not be zero. Epsilon and that one, so you can vary. So what I want us to try here is the time of vaccination, right? Can you just keep what? Just keep the same thing. Just go up. No, all those parameters we want to change TVAC. That's our TVAC. Can you go down, because we leave this epsilon and whatever non-zero? Can you go down slightly now? This is still no TVAC cannot be 0 to 1. So that's what you see. So this is what I said now. You have to, so TVAC might be 0 to what? Just put a number, even at 320.
Or 350.
Just even put 200.
Okay.
We are just trying now. We want to see the effect, but so you can put You can even start from 200, 300, depending on what you want to explain. For now, just leave it 5, only 5. Now go down. This is, now start time should be beyond that one. So put a slightly larger time span. Start time, I said start time. No, end time.
End time, yeah.
Just
Start time can still be 0.
Keep it as 0, yeah. Yeah, because we want to make sure that end time is takes. That's why I say that end time you just give it a large number and then keep it fixed. So your arc is only varying with the start time, and when you plot, you restrict the plotting whatever you plot.
Maybe just put 1000 Nandwa at end time.
Yeah, and then don't touch on the end time. Just give it a sufficient large number, and then don't touch anything on the end time. If anything, you limit your x-axis when plotting.
Okay.
And you are varying line 55, TVAC. And then I think everything is done. Can you go and x-limit your plot after the legend off? Because you didn't put this thing after the legend off.
Let me copy.
But you just copy only that one. So why limit should not even worry, because here there is no 0 here. Okay. You know, it's not now bringing the negatives. Have you copied it?
Yes.
No, I'm not seeing it.
You copied it.
I said after the legend show.
Legend show.
If you put within the loop, it means every time it loops, it x limits. Every time it loops, it x limits. So some of these things which is many constants, like the legend show, hold off, set, because they're constant, put them after the loop of plotting, after you plot all the figures. Just put from 0 to even to 400. But know that still so this value is not fixed, so you can still change it.
Yeah.
Right? Depending on how the figures are run. There's a problem. Unable to meet integration tolerances. No, can you? I just want to see why do you have these warnings? Can you? No, but I think there's something wrong with the solver, right? Can you go to your solver or this solver?
They're saying that the imaginary parts have been ignored.
I know. No, because so what is happening here is, can you go to, just go back to what? First of all, you can put this time, start time, end time is 1, 1, 1, all of them. No, start time in the initial condition. So that, but that's not an error. I'm just saying that so that you make sure that it's only saving values at 0, 1, 2, 3, 4 at the plot at the solution part. This initial condition, so there's nothing wrong about these initial conditions. What we did, start time, :1, end time. When you do this, it still will use automatic time to solve this, but it will only save values at the specified times, like the 0, 1, 2, 3, as you go on, right? But I know, but at least there is an error coming out. But so first, just enlarge this figure. So when you have the zero vaccination, when you start from initial vaccination value, right? And then the more you increase, the time of vaccination, that's at 50, at 100, at this, and then you have green at 200. But is it what we expect?
Yeah.
And what is this purple?
I don't know. It's
Purple is what, 150?
it's starting on the green at 150.
150.
There is one of these things where we are getting the errors. Can you just put them specific times instead of putting 0 to 200? Can you just put 0 and 200 only? Just put two numbers. Divide them into two parts only.
There.
But still, also this one capital. This one. There's a problem with the solution of this model, right? At time 200. Why at time 200? What did you put as vaccination parameter?
Yeah, vaccination.
TVAC, I think.
No. What's the vaccination parameter? Just
okay.
Theta is 0.2, and then it's 0.5.
TVAC.
Can you put epsilon to be 0.9? It's 0.9. If you close your Matlab and open, will it take a long time?
No. Let me close. I can close and then.
Yeah, I just want to be sure that there's because so. Why should it bring a problem when you?
How many minutes should I take?
When you just wanted to close so that you close the previous files.
Okay.
Is it opening?
Okay.
Now getting late. But at least maybe I think so. What you just have to look at is now this aspect of time. I don't know why Nanas Matlab is complaining. No, did you put also these codes in the shared folder that you shared?
No, I'll put them there.
Yeah, you can put the three things, and then I can also run some of them on my end from this end.
So they just general COVID-19, and then CL.
It's still those. It's still so wait for it to initialize because it's still initializing. You can still look at it. There are some of these comments, some of them you can remove them, which do not have even any issue, like line number 9 to 11, because you have so many comments. If you want to check some values, you find that some
9
of
to
them
11
so it's
will
ready.
not affect, because they are specific
comments. Those are comments. Are they doing anything in your program? No.
Oh, I can just delete them.
when anything which has percentages is not even doing anything in your program, and so they are just making your work. When you want to check some files, you find that your files are hidden. But so run, your MATLAB is ready. You did not even delete. Why is this thing not solving beyond 200? Can you put 100? Or maybe, what can I say? May first put 100 and then see what happens. Same problems. No, but at least you see the effect of what? But it's behaving. It's weird, right?
At the other time, the peaks were not almost the same.
No, because the other one, no. What do you expect? If you start vaccinating today, and then if you start vaccinating tomorrow, what is expected out?
So the place where they should actually.
I think it's supposed to be. I'm having this feeling that's supposed to be reversed.
So blue
because what is happening here is that this is just translating it to. Can you divide into 3 parts?
Okay.
And the first, what are we? I think we are plotting the correct variable. What I don't understand is, if you start vaccinating, then infections also start immediately. But if you hold on vaccination, yeah. Can you load wave 2? That's the one which also has vaccination. Can you try to load wave 2?
This one was
wave 1.
I
just want,
okay.
And then comment on line 17. You see, this one does not have an error. Now, can you enlarge it? But what is the interpretation of this? What is the interpretation of this thing? Huh?
Yeah, it's not even like like afterwards it remains constant.
Can you change initial condition for the second? No, can you change initial condition for the second wave? Can you use initial conditions for the second wave?
Okay.
So we might have this and then we fail to, but at least so there is something, so you can just have it. But so the question is, yeah, you know what the error is, right?
Yes.
Yeah. Oh, what are you looking for?
It's right there.
Yeah.
There. Yeah. It's late.
But with time we learn.
Yeah, it's the same thing.
Can you enlarge? Now this behaves a bit differently. So the first one, since vaccination is starting immediately, you don't see the effect of vaccination, right? Now the second one is vaccination comes, the second curve and the other one are, is this thing is labeling misplaced? No, but if you see the third curve, so that's what you see. Nando, first of all, Nando, can you please remove the Y limit? I told you why you put the Y limit for now. It's not necessary. You see now we cannot even look at what's happening at the top because you restricted you have a very large space at the top.
Yes.
So can you remove the Y limit? Just put
from
percentage.
0 to N0. Yeah.
We want to observe the peaks.
Okay.
Yeah. So no, but you see now. So I think now you can now see the differences, right? You see the other end. So they were too small, and so somebody could think that they are the same. That's why I was wondering, and I think maybe because they were too small. But so if you check this, and this is what is expected, that when you put in vaccination, the purpose is what? You are reducing the number of infections. And so the question is, when should we vaccinate? Should you start immediately? Should you wait at least for some people to be infected before you start vaccination? And according to this, what does it tell you?
You'll start immediately.
No. Why do you start immediately? Because first of all, the end, everything goes to the same value. So it means in the end, nothing changes. But so look at the peak. The blue curve, if you start immediately, you have peak. The peak is high. The more you increase, you increase the range of vaccination, the faster, the lower the number of infections, right? So you see, if somebody who started vaccination immediately, you have, for example, the highest number of the peak is at close to 12 times 10 to the power 6 over, right? When you are at time 50, the peak reduces. At time 100, the peak keeps on reducing.
Yeah.
And so you see, so what will you recommend to somebody?
To start vaccination late.
so this is something else, because what I say is, I know maybe we are in a group, so many, and some people may have an interpretation of this.
Yeah.
So you see, like this figure, when you put there in the file, right? In the overleaf Nando, because you put these figures. So only speak the visual interpretation. That when, for example, when we increase the time of, the late we vaccinate, then we find that the peak decreases. So you can just speak in terms of this. So we investigate the effect of vaccination and the time of when should we vaccinate. And say that when you vaccinate earlier, maybe you have high infections. The more you get late vaccinated, the more you have low infections. And then I think we have so many people in the group who are doing kind of this modeling. They may have maybe a physical interpretation. So when somebody is there, they can now bring in the physical interpretation of this in the discussion. So with you, mathematically, you discuss what you see, and then what you can say, that when you increase, the more you delay in vaccinating, the lower the number of infections. Yeah. And then the others, let the people who have the ideas about the physical meaning will now bring in now the physical interpretation, that actually this means this. But this is what but at least it's what we see, you're at least having something. If it's what we expect, we don't know. But at least mathematically and computationally, you can present the computations, thus explain them computationally without making reference to the biological effect. And then if somebody has an idea, then they now bring in the biological explanation.
Yeah.
Can you increase the number of subdivisions?
Yeah.
5.
Yeah, 5. You can even you could have even increase to 100 to even 200. Can you now see it? When you have zero
The
is
same
high,
trend, yeah.
the same trend. So you see, like these figures, you just plot this figure, and then you can even limit your range to even 350, right? Can you increase the time of vaccination a bit, and then you add one number? I just want to see this trend, because at the end we had 320, so you can put 320.
Okay.
320.
Yeah.
And then you have left the same place where you have to change. It's at the loop. You are changing the maximum value to be, instead of 100, you are putting 320. Where do you have epsilon defined? That one. You can put 320 and even put 6 values, even 7, whichever that you feel is sufficient to explain, right? So these are not scars that you have to maybe put 10, put 5. Yeah.
Oh.
And some oh, and I think so. So this is one. I think we are doing this with now in some study with another professor in Kenya, Professor Ogana. Maybe you might know him.
Wandera
Ogana, yeah. So the other things we are doing is we wanted to see what is the effect of vaccination. For example, when you introduce, for example, so vaccination is like a mitigation effect, right? So what's the effect of mitigation when you introduce it before the expected peak or after the expected peak, right? Yeah, and so you see, when you produce it before the expected peak, you find that these things, like they are reducing, right?
Yes.
And but after, you are having like now the double peak. Yeah, you have something like a surge, and then an increase, but so you keep going to the same value.
Yeah.
So you can put this in 2 phases, and then we will see what happens. It means also vaccination also can also lead to another outbreak, right? Yeah, this is what it because you see that if you start vaccination at maybe time 320, we are having another, you see another, the curves, the vaccination goes to 0, but now comes up. You see the other 3 waves.
Yes.
What does it mean? Does it have some meaning biologically? We don't know, but at least that's something we have, right? And it's one of the things what we are, some of the computation I'm doing with the other project I'm telling that we do with Nando. So we look at 2 types of interventions, vaccination and relaxation. But so we focus on non-pharmaceutical interventions, the lockdowns, whatever. And so we look at the effect when you introduce it before the expected peak and after the expected peak. And you are able to show that if you introduce this intervention after the expected peak, then you lead to an emergence of a wave. The wave starts forming, but that wave is not sustainable. So for you to sustain it, then we introduce periodicity. Yeah, so you see, so something like, and I see almost the same thing here, because vaccination is just a mitigation.
Yeah, of course. It's
Yeah,
not like a cure.
No, yeah, it's just something you are putting to control the disease. And so Nando, you can put these figures in 2 parts, and then you discuss this, right? No, maybe. Oh, so what will I say? So for the second wave, you use the second wave, then it will help you explain this effect of vaccination, maybe like at 320, right? But if you go to the third wave and still keep the same 320, you know that the third wave, the expected peak comes after time 320, right? Or maybe around there, or the fourth wave.
Yes.
Can you just read the third wave and do the same thing, but read the third wave? Just close the figure and go back to Matlab. So load the third wave. That's what I'm saying in short. And so you know what, when you load the third wave, you only change what you read and change the initial condition.
Yeah.
And maybe for now, can you try to put that 3? Can you try to put? Oh, I think we could have done, but it's okay. We could have put the time from 250. No, but so we are just discussing theoretically the effect of mitigation. But if we want to see the effect of vaccination on what happened on these waves, then you will use the actual times. Like if you go to the second wave, you will use the actual times from 250 to maybe just from 250 onwards.
Okay. The initial, okay.
Yeah, I said don't touch on the on the end times. Only just look at what, focus on this other one. Can you run this? No, open it. But also they are decreasing, right?
Yeah.
But so there is something forming on this the down curve. So some of this, who knows, who understands? Can you put time? Third wave starts from time 4. Can you put time 450? Initial time, the start time as 450. I think third wave starts from 450, right?
Yes.
You have these warnings. Yeah, this is just because of the restriction in the plotting. No, just put 0 and then at least no, but at least we have seen, because so instead of doing this and just put 0 and then leave 1,000, and then you can keep the second wave. You can also put the fourth wave and so on. And then you can discuss this. And so what else is remaining?
No,
is there anything else we want to investigate?
I think the next is to do the graphs and then give the explanations as you have said. The graphs you have done actually for when you are being general and then this variation.
The variations, and at least we have also seen the variation for the time. And is there something we can calculate here? Maybe we want to check those vaccinations. For example, you want to, what is the correspondence between the decrease in the peak and the increase in the, are they related?
The increase in the peak and the decrease in the infection?
The increase in the lag in the time you take to vaccinate, and the decrease in the peaks. Do they have some relationship? We don't know. But we can read, because at each time you read, you find the wave, and then you find the peak. And then from that peak, and then you can now study the peak, and then you see if there's a relationship between the peaks and that increase. But that one, if you put, I can check it. I just, because it's just it's the same code. You just, once you plot and then you look for the peak just by using the find the peaks. Or maximum, because we want the maximum, right? Yeah, so you can just, can you go somewhere in the table? No, not in the table, in the loop. Once you solve the model, right? Can you just immediately after solving, after the solution, immediately after solution part, which is line 60, anywhere from there, because you have, I saw you have so many comments here, which some of them I don't know what You can remove them unless you know what they mean, but don't remove them for now. Just keep, because so I want to find the maximum of each of these curves, right? Like particularly of the infection. And so first of all, we have seen effects of this on Y4. Can you plot Y3? First, just I want to see what's happening to Y3. Just put Y3, but don't run it. We will run it together when you have the peaks, right? Just put Y3 there.
Three.
Yeah, it's vaccination. I want to see how don't run it. We will run together when we are finding the peaks. Can you now find the peaks at line 62? Just maybe put any label, even inf peaks. Whichever label you want to, I'm finding I want to find the maximum. So which name do you want to give them? I want to find the maximum of infection at every time I vary that every time I vary the time of infection, I find the maximum of that curve. So
maybe
give any name.
Max peak.
Or max inf, so that because it's infections.
Oh, okay, yeah, max inf. Yeah. F, just put an F, I think.
So what I say said is, so what I wanted, Nando, is you look for an appropriate name that can describe what you want. And because it's not unique, you can give it whichever name you want. That's an output. You can define it the way you want, you'll define it, because it's how you want to store whatever is coming in, right? Into bracket J, because you want to store every time at the value J is equal to is equal to, again, in the bracket. Then you have removed the J. And then you find the max Y, just whatever you are doing, Y colon max into bracket Y colon 4. Y into bracket. When you read a vector, you see how you are plotting it. How are you plotting the same thing? I just want you to put how you are plotting it.
It's right there. I think Y3.
Why this vaccination? Because we want to find infection, so it is Y4.
Oh,
right?
Okay.
I think there's a balance of brackets, or yeah, that's Y4, and then divide by N naught, multiply by 100. Yeah, just know that. So you can even divide everything, all of it. Just even you can put the division outside. Divide by N naught, multiply by 100. Yeah, because you can put semicolon. What I want is just get these peaks and not inside of, I find the percentages of these peaks. That's why I'm dividing by the total population in the fraction and then multiply by 100. Now just compile it. So you see effect of this on vaccination. But there's this curve, because of this error you're getting, there's one of these things which is not solving to the end, right? So you have the error warning, this warning error is what's happening at that time, 300. You can try to use another ODE solver later, right? But so you see the effect of this on now the vaccinated group. You can check the effect on the recovered, right?
Yeah.
So you can just do the same thing, but you plot different curves. Effect on the vaccinated, effect on the recovered, effect on what? Infections, vaccinated, and then the recovered, but maybe not susceptible. Now, can you just minimize it and then check max I? Whatever you saved, is it max in J? Check it even in the work. It's supposed to be in the workspace. Don't even like put it in the command window. Just double click in the workspace. I think you opened some file with D23S.
Yeah, there. 50.
50. 6.4.2 12. So no, I think this 12, because of the error, the other parts are not computing. The three other, the last four curves are not computing, right? Can you put what we did this with? Can you put the second wave? I think it was
second wave will not bring these errors here.
Yeah, and so you will check this, some of this, what the error is. Can you just read the second wave? And then you have to read the correct one. Now proceed. Yeah, because you limited the time of plotting, so you cannot see where the curves are going. That's why I said, so don't limit your time of plotting so early, or even don't limit y-axis so early. You will limit once you say that this is what I want, and then you limit and plot, right?
Yes.
You see, even here you have some negatives, so don't limit yourself so early about this plotting. But so check now the max. Just no, leave the figure alone. Just check the max in.
I think it's 20.
Yeah, it's 2018. Enter. Just click enter.
Yeah.
2018, 11, 10, 10.7. The others are fixed, right?
Yeah.
So what does it mean that these other fixed?
We still have an error.
It decreases after some. No, I think not an error. Can you plot inflections, Nando? I think the others, because after the peak now, you start forming another wave.
Okay.
And that wave goes to a constant number. You see what was happening? Can you plot y4? Just plotting. Line 70. Plotting is after the solution. So it's supposed to be at line 70. So is it 7? Yeah, 4.
Yeah.
You see the other peaks. After the first three, then these others, since they are setting down, so they form a small wave, but so you have the same maximum number. So you keep the same wave and the same peak. The difference is that it's now lagged, right?
Yeah.
Yeah, so the wave is lagged. So in fact, we can extract the two things here. Once you find the maximum, you can find the time point at where the maximum is appearing, and then you can see the differences. No, but I'm just saying, I don't know if these things will give us some information, right?
Yeah.
I don't know, but so what I said is, some of them, you have them, and then you might find that they give you some information, some interesting thing. If you get some relationship, either with the lags or what, right? No, but I think these lags here should be, I don't know, I think they should correspond to the time differences of the time where you introduce the vaccination. I suspect, but I'm not sure. But maybe they might. But so I will check this. But I think this is enough for today. So just Nando to put the figures.
Okay. And Nando, I think don't forget the Y label as well.
Yes. So Y label you put it up.
Then now this time round when I do labeling the
and make sure that you see your figures. Some of them are rectangles. Save figures I think in a squared format, I think square is okay.
So I say
no, just you see how you saved your figures. Don't enlarge this figure when you want to save. Just
like
when you compile it, save it the way it is without enlarging it. No, you know this is enlarged. You see this is enlarged already. So when you save it, it will appear as a rectangle.
Oh.
Can you
So,
run?
like, if I run?
Then save it.
And then I go to save as.
Yeah, save as. The way you just saved the other end.
Okay.
And then you change it to PNG down there. Okay. You can put some of them. Some of them want EPA, some of them, but I always use
What
PNG.
is the best format?
Okay, it depends with the journals.
So, but
mostly,
by the one.
Sometimes when you are doing, I export TIF and PNG or API, EPS, whichever. But so that's why when you compile and you submit the articles, don't be quick even to delete your codes. Don't be quick to some of them will tell you to produce new figures. Yeah, with the high compression rate. So that when they enlarge, you still have figure. Things are not blurred when they enlarge. Yeah. And so for now, you can just keep the PNG. But later, depending on the journal we decide to submit to, that will determine the type of figures they may need. But mostly PNG.
Okay.
And the naming as well of the figures.
Yeah, try to put names which at least when you put these figures, we can easily follow.
Okay.
For example, this one you are writing the TVAC, right?
Yes.
So what can you say? Maybe you can even put something just like TVAC vary W2, maybe whatever something, and then underscore INF. If it's for the infection, if it's for the so you see these names, TVAC maybe underscore W2 underscore inf. Some of those, in this figure they are varying the time of vaccination, because for us we know what TVAC is. And the others, because the other group members will see these figures in the report, and you will have put the legendary caption, so that one they don't have a problem. But for us, we can easily follow in the Dropbox. We can see these figures, the ones you produce. So when you put something like TVAC underscore W, like if this is Web 2, W2 underscore infection, so you know, this varying the vaccination time, but now for the infection, you may have the same figure for the vaccination, the same figure for similar figure for recovered. Right?
Yes.
Yeah.
And I just wanted to vary, but no, I think that you'll just put the code. I'll add another loop. I wanted to see effect of two parameters, like one which is increasing and one which is decreasing, right? For example, the beta and the phi. Because beta is increasing, phi is decreasing. So maybe we want somewhere a balance between these two parameters. Yeah, so that one, the same way you made the loop here, you can create two loops. You just put one loop outside the other one, and then it means in that loop you will be varying two parameters at a go. And then you can investigate the peaks. You look at now the peaks, and you start now looking. You want to see which is which combination of beta and phi can give us maybe the least number of infections. Yeah, so I just give a beta on phi, but somebody can see even beta and vaccinated, maybe phi and vaccinated and whatever. So those, you see the combination of them that gives us minimum, mostly those parameters which are opposing each other. Yeah. But I think if I think since we are, I think it's, I don't know if it's late.